Welcome everybody. This is an introduction to service workers. My name is Aaron Manire. I have all these slides online. You can go to that URL and follow along on your laptops if you would like to as well. I am the Director of Web Development at Isavera. We're based in Waltham, about 20 minutes down the road, depending on traffic from here. Maybe not so far with traffic, I suppose that's about right. I've been at Isavera since 2011, so it's been a while. And actually that was before the blog post, I believe it was, on responsive web design first came out by Ethan Marcotte. And I remember dabbling a little with responsive web approaches, media queries and things like that, and thinking, I think this is going to be a thing. We should probably build websites like this. And I had to actually kind of pitch it and present it. And I kind of get that sense with server kind of phenomenon. So you're probably wondering, by the way, I should also mention Isavera is hiring. If you're interested, we did have a table. You could also just go to isavera.com and take a look. So anyway, service workers. So you're probably wondering, or actually, how many people already have some idea or know what a service worker is to some extent? A couple, okay. Cool, then you're at the right session. You might hear that phrase and think of something like this, and you wouldn't be far off. And it does have kind of a very generic, complicated back end, something really possibly dangerous happening with people who really know what they're doing, and you probably want to stay out of their way. You wouldn't be too far off from that definition. Before I actually explain, though, what a service worker is, I'm going to tell you about what Web Workers API is. Haven't seen too many of these lately, but they were around quite a bit in, 5, 6 years ago. You'd get these. The website has become unresponsive. I was actually looking for an Internet Explorer version of this. I didn't get one, but you've all seen something like this before, though, right? With a JavaScript error. So that's the kind of thing that the Web Workers API was set up to address. And what Web Workers does is it provides this API for having multi-threaded scripts running in the background independent of the DOM. You can have these scripts be very high performance, using lots of memory, but without any impact on the browser, the windows, and the user's interaction. One example that I had seen of a really kind of proof of concept, it's actually very popular if you Google calculate pi with a web worker, you'll get a lot of results. And it's not terribly practical to actually use this, but what you can do is run a web worker script that just runs in the background and calculates pi versus doing it in the DOM and ending up with something like this, because your browser is just spending all of its processor just doing calculations and then timing out. One kind of web worker is shared worker, which allows different worker scripts like that to communicate and share information between themselves. Another kind of audio web worker I've seen is audio workers, which let you do processing of audio. I haven't actually used, or haven't consciously used an audio worker, but they're out there and it's a supported spec. And of course, service workers, another kind. So what problems do service workers solve? And the big one that's getting a lot of attention, that's popular, is providing an offline experience on the web. And not just offline, but even when you have a kind of weak connection, you're assuming when you're working as a web developer, kind of unconsciously, that people will have good bandwidth and these kinds of things, but that's not always the case, especially on mobile devices. It can also reduce the traffic to the web servers because, well, I'll explain why. And service workers can also improve customer engagement with offline notifications. This can also be really annoying, and it's starting to be a thing right now of abusing web notifications. I'm not going to talk about those too much in this session, but that's something they can do. They also don't have great cross-browser support right now, with Safari in particular. And service workers can also provide an ability to do background synchronization. This has even more limited support than, or I should say, has less support cross-browser than offline notifications, but it does allow you to do things like complete a form transaction when you lose internet connection. And potentially, a service worker might eliminate the need to have a native app, an iOS or an Android app. Even a Windows app could potentially be replaced by a website that has a service worker. So just a reminder, if your website has a long load time, 1 to 3 seconds, you're going to get people bouncing, and it's like one of the biggest problems with sites. That if it takes more than 1 to 3 seconds, you're going to get a bounce rate of 32%, according to Google a couple years ago. If it goes to 5 seconds, that bounce rate really starts to skyrocket to 90%, up to 123% at 10 seconds. People just don't even stick around. So, yeah, a shout out to Mo Willems. It's actually Mo Willems, not Williams. I spelled the name wrong. Like I said, I have kids, and waiting is not easy, especially on a mobile phone. So this is what a typical network request would look like. Obviously, oversimplifying here. There could be a CDN. There could be all kinds of things on the network side. But you end up with failure and frustration when there's potentially no nearby cell tower. Your Wi-Fi is kind of on the fritz for some reason. Maybe there's a lot of people using cell towers or the traffic, problems with ISPs. I actually, while working on this session, experienced a power outage. Slack actually kept chugging away, didn't care that the internet was down. That's the kind of thing, though Slack is an Electron app, it's something that also a service worker can kind of provide that continuity with. And your server can actually go down and still and cause an outage. That's the kind of thing that a service worker can address. So when you throw a service worker in the mix, you end up something like this scenario, where the service worker is kind of this personal man in the middle between your device and the network, and it's basically mediating that with its own cache, and that all happens through this fetch event. This is kind of like a Drupal hook, where it's intercepting all these, potentially any fetch from the browser. Actually, it is every fetch request from the browser, and possibly altering that fetch event. And so I just also want to be realistic and be clear that there are certain things that service workers do not address. It's not going to do anything for that first site visit for users. So it's an enhancement on top of all the kinds of caching and performance optimization that you already have to do for that initial site visit. And it does increase, it adds a layer of complexity to your caches. So you could have a CDN, you could have varnish, you could have Drupal dynamic page cache, and it's another layer on top of that. So in the build process, you're adding more work and potentially more demand on the skill set for maintenance. So just want to put those caveats in there. It's not a silver bullet. It does bring potentially more technical debt along to the project. So what do you need to work with Service Worker? You need a compatible browser. And let me see if I can do this without, oh, I gotta pop out of full screen. You may be surprised, I don't know, to know that cross-browser support for service workers is really good right now. IE being the notable exception to desktop browsers. Opera Mini, the sort of typical neglected mobile browser. But iOS Safari and Safari now support service workers as of about a year ago. I don't remember the exact date. But that was sort of a big threshold that we crossed last year for service workers. And all those browsers that support service workers, if you have service worker support in a browser, it's also going to have support for ES6. So all the examples that I'm showing here are using JavaScript, ECMAScript, what is it, 2015 or whatever, ES6, right? So that's nice because then you actually, if you're just coding a service worker, you don't have to use transpiler to support older browsers that can't support it. And you'll see the example for that. But just fair warning that my code examples are all in ES6. And if you are not familiar with ES6, there's some great resources out there. Wes Boss has some online courses. But if you just Google ES6, you'll find plenty of resources for getting up to speed. And you will need an SSL HTTPS browser connection to use Service Worker. Like I said, it's kind of your personal man in the middle, which from a security perspective, man in the middle, when you hear that phrase, you're probably tensing up because that's a vulnerability and could cause disastrous consequences if somebody's intercepting your network traffic without your knowledge. So you have to have a secure connection for this to work. You also need to have a same origin policy for scripts on the page for this to work with it. There's a lifecycle when setting up a service worker on a site, which starts when you first go to the site. You download the service worker into the browser. It installs, and it activates for the page. Now, on subsequent changes to a service worker, you're going to go through that same process of downloading, installing, and then there's going to be this period where you have a service worker available, but it's waiting to take control over the page from the previous version of the service worker, and it requires that all the windows and tabs are closed for that to happen, and then it will activate. This will start to make more sense when I get into the details of how this actually do. So, how many of you here are familiar with the promises in JavaScript? A few. Okay. This is a feature of ES6 and heavily used in service worker code. So, but you can also code your own promises as well. And a promise in JavaScript code, or in any language actually, I think Java had promises years ago before we saw in JavaScript. And a promise is basically an IOU in code that eventually will have an outcome of either being fulfilled or rejected. And it's sort of it's a way to work asynchronously with a thread and chain together events. So to create a promise, you're going to write code something like this, and it's basically an if-then statement, and you're providing some kind of return value depending on whether it was successful or not, based on some logic to actually do the promise. To use that promise, we have a piece of code like this, where we have our promise, and we use this then method on that object, and our argument coming through from the results of that promise being passed through, either being successful, and in both of these cases we're logging the results here, or as an error and catching it in this case. And this could take place in milliseconds, or it could take place in 10 seconds. But the point is that your code doesn't rely on it's not working synchronously. And then you can chain promises together, so you can have a known sequence of steps in code that are not blocking anything else, but do require a previous step to occur. So just adding in another step here of logging the data from our result. So this is building on top of here, where we have our result, and then logging that as the actual data of that request. So the two key APIs that web services use, service workers use are fetch API and cache API. So both promise-based. They're used heavily inside service workers, but you can actually use these outside of a service worker script. Just like we saw from that promise template, this is an example of a fetch. So we have calling a fetch object here, making the request, and we get a response back from the fetch, and just logging the answers here. So I have an example that I can show in real life. Close this tab. There's not much to see on the page. All right, already actually ran, so I'm going to, let's see. I'm going to put this, so this is a page with a script inside of it. Let me show you what that actually looks like. All right. Let me bump up the font size here. There. Can you all read that?
Yeah.
Okay. So, I am creating a promise here that's going to fetch my user account from GitHub. It's an open API. Then it's going to log that promise, and calling the then method, it's going to log a response right here from that request. Then it's going to parse that and either log data or an error if nothing is retrieved. So I put the site offline here, and if I go back and reload, there we go. So We got an error trying to fetch the script, which is what we would expect because it's offline. There's no service worker set up to do, but we can't actually do that with a network request with a service worker. And if, oh, it actually blew away the page. Interesting. All right. Technical problem here. I think my server, let's try that again. To actually do the fetch request, I have to run this locally. Let me try that again. Shoot. All right. I'm not sure what happened to that script. It seems like it's disappeared. There we go. All right, let's try that again. Yes. Okay. So just trust me that it actually just made the call out to GitHub. Before it even made that call, though, it created this promise object, and we got a response back. This is what that response object looks like, and we can go and look in the body here, where we would expect our data, but it's actually returning a stream. If you saw the code, we had to actually pass that and here, get call this JSON method and get that parsed back in a JSON object. So there's the actual data from a request to GitHub being logged back. So, of course, doing it live, we're going to run into some issues, but that actually made that request successfully to GitHub just now. Okay. All right. So that's an example of a fetch API request. All right. Yeah, sure.
Would you mind sliding back one slide?
Mm-hmm.
Is that hooking up to then things, or do those actually get forced to run sequentially?
They're running sequentially, right? Okay. So this return. So this method is not going to run until this is going to run, and it's passing that response. This return is getting passed in as data here. Gotcha. So those are arrow functions. Yes, that's arrow functions that are passing and returning that through. Does that answer your question?
Yep, thank you.
Cool. Any other questions on this fetches? If you did write this code, by the way, this is just embedded in the body of the page that would fail on older browsers, right? Because this is ES6 code, so just a fair warning for that demo. Okay, now the cache API. So the Service Worker Nightly spec has a great quote. So I think I have the link at the bottom of this when I get through it, but cache instances are not part of the browser HTTP cache. The updates must be manually managed, and authors should version their caches by name. So this is coming from the Service Worker Nightly spec. You can go to that URL. And what it's saying right here is that as a developer, when you're working with the cache API, you're responsible here. There was, prior to the cache API, there was an API called AppCache. It's still around. Has anybody heard of AppCache? Okay, it failed, crashed and burned miserably, and basically was trying to accomplish what Cache API does now, but in a more declarative way and was prone to just being inflexible. Jake Archibald, who's been very active with the service workers at Google, wrote a blog post called App Cache is a Douchebag, I think, in 2014 maybe, and we haven't really heard much about it since. But Cache API is a much more modern and useful replacement to App Cache. So Cache API basically lets you work with an open cache in the browser, and it's not the same thing as your browser's HTTP or disk cache or the browser's memory cache. It's its own separate set of cache objects. And they're associated with your site or the domain. They are there for you to manage, and I'll show you how to do that. This order right here shows you the precedence that those different caches take in the browser as well. To use the Cache API, first you'll want to open cache using the caches property of cache storage. You'll get a whole bunch of methods associated with that cache object. This is just a sample. But basically you can add stuff to the cache. You can do it a single item, multiple as an array, and then you can match things from within the cache and pull them out and delete things from the cache and so on, as you would expect. So similar to we saw a promise, like we saw with fetch, here's a promise to add a offline HTML page into our cache. Right? It's a single URL and all the markup inside that HTML file go into the cache. Right, pretty simple. So, like all these things I'm talking about, once I get to like some of the tools and show you in dev tools, this will start to make a lot of sense, I think, for you. So to build a service worker, first we start with HTTPS. We have a domain with it's secure. You can also use localhost locally, which is also considered secure. So that makes development a lot easier because if you think about this, if you've worked with local HTTPS connection, you're probably using self-signed certificates, and service workers do not like self-signed certificates, so you have to actually either spin up an instance of your browser that says, ignore that self-signed certificate warning, show me the site anyway, I know what I'm doing. So you can either do that, or much easier is to actually just work with HTTP with localhost. Then you just need to register your service worker script and write your service worker JavaScript file. It's basically to get that in place. And then the hard part is thinking about what you're actually going to do with your service worker, what your strategy is here. And there's a lot of options and a lot of potential. So for HTTPS, you can buy certificates. Just note that you can also get free certificates now with Let's Encrypt. And if you're using Let's Encrypt, you probably need to use certbot, so you have auto renewals, so your certificates don't expire in 3 months when you forgot to upload them again. So, to register a service worker, which you can do in a very simple example on an index.html page, is just add an inline script like this. That's basically checking in the window navigator object if there is a service worker property. So if there is, we're going to call this register method on the service worker and point it at our file. And that will register the service worker. And since this is in the DOM, you don't want to be using ES6. Or you're going to need to transpile whatever code you have there, right, for cross-browser compatibility. And it's important to think of service workers as a progressive enhancement. If the browser doesn't have a service worker object in the navigator object, it's just going to ignore this entirely. It's not going to try to load the service worker, and it's just going to move on. So during this registration, you can also specify a scope for the service worker. So tell it not to maybe apply to the whole site, but only a subset of the URLs on the site. So that's something that can be passed in.
Is that scope only URL based, or are there other ways to scope it?
I had assumed it was URL based, but I'm not sure. Actually, it's a good question. Is there another approach that you're thinking of?
Just your own vars or hashes or time, or I don't know, just curious. It's not a big deal.
Yeah, I assume it's URL based, but I don't actually know if there are other approaches.
Right.
So then we're going to actually start to write our service worker file, and I think this is where you'll see the meat and potatoes happen here. So as I mentioned earlier, when it comes to dealing with your cache, you're going to want to create a version cache name. And this is how you would do it. So just giving your cache a name and then appending a version to it. So then within that service worker JavaScript file, there are 3 events that correspond to that lifecycle I showed you earlier. We have an event listener that we can add for installing, another one for the activation, and then the man in the middle event of intercepting the fetch events, every fetch event that the browser on that site is doing. So to put a little, specifics here so that it starts to make sense in terms of a caching strategy, that on that install event, we're probably going to put some stuff in the cache right away. So if we want to have an offline fallback for our site, right when somebody first goes to visit the site, we're going to actually start putting in that offline HTML page into the cache. Once it activates, that's actually a good opportunity to clean up older caches on the site. So we would do that there. And then when fetches start happening, we're either going to be just passing that fetch right through and not doing anything, or pulling something from the cache. So looking at an install event, we have a cache name already, and we can we're going to use some more asynchronous language here. We have a wait until method, which is basically going to make sure everything completes first before it actually moves on. And so it's opening this cache, the cache name, my SW cache version 1 right here. And it's going to add this offline HTML page. We also want to add our styles.css file as well to the cache, because if it's offline and you don't have any styles, it's not going to look so great if you have an extra style sheet. So we're going to put that in the cache as well. Then in the activate event, in this code example, what we're going to do is get all the keys of our cache. That was one of the methods that we have on our cache. And so instead of like a for each, we're going to use this map method on each instance of our to get an instance of each cache object in the cache, and then say, okay, is that key the current cache name? If not, we're going to delete that, right? So we want to just keep the one current cache instance in our cache. Any questions about that code example? Is that, I'll get out there for a minute. Yeah, so we can't use a for each because it's all the methods and code has to be done with asynchronous methods in a service worker. All right. So in our fetch event, we're going to, for this particular strategy, we're going to say, okay, HTML files, we're going to try to get directly from the network so we get the most up-to-date content and return that. But if for some reason we don't get a response from the network, then we're going to fall back to this offline.html page. And with everything else, we're going to just go right to the cache. And so CSS, images, this is a very simple example. This maybe would not work on a very advanced Drupal site, but the idea is that we're just going to return those assets directly from the cache and not even connect to the network for them. So with this code, we are going to intercept that fetch event and look at the request right here and say, okay, in our accept headers, is it text HTML? Is that a part of the header? And if so, we're going to respond with, we're just going to pass through that response from the fetch, right? We're just passing it right through. But if that fails, if this fetch event fails right here, instead, we're going to look in the cache with this match method and see if there's an offline page and then return that instead. So if it's text HTML, go right to the network, and then if there's an error, return from the cache.
And in real life, you'd probably want to update the cache if that succeeds.
Potentially, yeah. This is just one scenario, right? There's all kinds of scenarios for how you would approach the caching strategy or the whole the service worker approach. So, yeah, sure.
Kind of a follow-up question. Then, so you said this is separate from the HTTP cache.
Mm-hmm.
So if the HTTP cache is already cached that HTML page, is it, from this point of view, is it going to the network, or
remember,
does it succeed?
yes, it will. The precedence of the cache is before the HTTP cache. If you remember, there was memory cache from memory, which is very short-lived. Then there's the cache, the service worker cache, and then HTTP cache. So it's going to look in that sequence.
And so when this fetch, is a successful fetch always a network call?
Yes.
Or is it ever a fetch out of the HTTP cache?
It's a network call. Yeah. So, yeah, because it's going to go through those caches in that order, right? So it's if I'd have to test that out to be sure, but I think it will fail. Yeah, it would definitely fail because it's going to try to actually hit the network. Yeah. Okay. So, yeah. All right. So that was for the HTML, the index.html page, and then in the case of CSS and images, we're going to do a match, pass that into our match event, and if that matches, we're going to return the response from the cache. And if it's not in the cache, then we're going to just pass that to the network. Right? So that is just one example of a caching strategy. And another example is if you want to put a limit to the amount of time that it's connecting to the network. Mozilla put together a site, it's not easy to say that, servicework.rs, service workers. And you can actually go to the site. It's a great resource. It's in the resource section here, and they have a bunch of different approaches to working with service workers. And you can actually go in here and look at a demo. So what this example is going to do is it's going to see, so if the network, I'll just read it. If the network fails or the response is not served before a timeout, it's going to stop the network request and return a cache version. But if it fulfills without the timeout, exceeding the timeout, then it returns the file from the network. So see that request. Every time I refresh, it's not a problem. And if I go back into my dev tools, let me put this at the bottom of the screen. And oops, I'm going to throttle this at slow 3G. All right. And make that request again. We're going to see that actually pull back the same images. Let's try it again. All right. You can see we're looking at two different images now. This one pulling from the cache. And if we look at our dev tools here, I think you'll start to find this very intriguing. Quite a few images on this page, but oops. Over on the sides, we can see where the images actually came from, and here we can see the two different assets, and one of them, this second PNG here, returned from the service worker rather than the network. And let's see the actual code. So I think that was a 400 millisecond limit. I'm not going to explain all the code here because I'll get bogged down on it, but you can go in and look at it. So it's checking to see if it takes longer than 400 milliseconds, and then returning the cached example. So I guess while I'm in here, this is actually where it starts to get really kind of fun to play around with. I'm going to show you some of the dev tools. So you can actually go in. I couldn't find an equivalent in Firefox, so I'm going to use Chrome as an example. And also Edge Canary has the same exact engine running now, so you can do the same thing in Edge as well. That's on a Mac as well. And if I go into my cache storage here, and network or cache, I can see that asset. I can't actually look at it, but that is the asset that was stored inside the cache right there, and it's also caching an HTML file as well. Shoot, I'm running out of time. I'm going to move real quick here. Another strategy that you can use is, like I said, there's plenty of strategies. Another pretty interesting one here, which is not quite a caching strategy, but it's another example of using service workers to do this intercept on the fetch event. And we can actually detect if browser supports WebP and return a request to a WebP file rather than a JPEG file for an image. So it's sort of a performance enhancement to browsers that support WebP using service workers. So you can check out that URL for it. This tips and gotchas. So this page has a lot of great tips working with Chrome developer tools. And by the way, this whole presentation, I gave you the link at the beginning, is actually running in a service worker. Here we go. And if you go to Application Service Workers in Chrome DevTools, you can see information about that service worker right here. You can switch to offline and access it offline and test it that way. And if you click on this tab down here, you can actually see all the service workers currently installed in your browser and filter. It's not a great search interface. Could be optimized, but yeah, like see all the different domains that are running service workers on your site for different sites for your browser, and you can look at what's stored in the cache. So for this slide deck, these are all cached in the browser, and it will pull offline from this cache. And there's the index.html file right there. I don't know why I can't pull that. There we go. Yeah, so lots of good information on Chrome DevTools there. You can also, working within browser, you can set a console context to work on the service worker directly. You're seeing these arrows because is it actually an offline mode? But anyway, if you set it to the service worker context here, you can interact with the service worker directly with events in the browser. One thing you need to watch out for is if you don't do anything about it, a service worker will have to wait for a navigation event for the user to click something for it to reload. You can add a couple of events, methods, skip waiting or client's claim to basically immediately replace a service worker with a new one. So that's something to be careful about. How many people have heard of Lighthouse? For not just service workers, obviously, but for accessibility, responsiveness, performance. And Lighthouse has also, I don't know, maybe it's always had PWAs, progressive web apps, as something that it's included as part of the audit. It's definitely worth playing around with Lighthouse to work on service workers. And on the topic of progressive web apps, which is a big one, but I do want to mention this blog post that basically is giving kind of more of a marketing wrapper to service workers and building kind of a new wave of sites out there that are responsive, they're independent of connectivity, so that's something you get with a service worker, and provide all these kinds of features. And Jeremy Keith, who did a keynote at Design for Drupal last year, he also has a book on service workers and offline, and it was part of the inspiration for me to put this together. He wrote a post about how any site can be a progressive web app. It's just a matter of adding HTTPS, a service worker file, and a manifest JSON file. So those three ingredients can basically give you a minimum PWA on to turn your site into a PWA. So a manifest file, real quick, is just a. How many people have heard of a manifest JSON file for PWAs? Okay, so it's basically just a JSON file declaring things like on an Android device, when you save this app, when you open this app, do you want to use it in a web browser, or do you want to actually make it look like an app with no browser Chrome navigation? What do you want to use for the icon? What color should the background be? These kinds of things. And this is more like a topic unto itself, but there's a discussion to actually make Drupal core offline. I think I'm going to run out of time, so I'm going to go through this real quick. But there are Drupal solutions that there's a service worker module that is abandoned. I wouldn't recommend that. There's a service worker registration module, which will give you a very simple service worker integration. And there's also a module called the Progressive Web App module. There is no D8 release, but there is an issue that is being very actively developed right now to get that ported to D8. And I would suggest, if you want to really have if you have a Drupal site that you can spin up and you want to just dabble with service workers and progressive web apps, keep an eye on this module. It's not ready yet. It's very active development. But what it does is it gives you this configuration screen where you can actually just go in and specify things like what I want to cache, what I want to exclude, what my cache version is right here. And then I can configure a manifest file right through the UI as well, and you can see the options here. It's giving it a name, description, how it should display on an Android device, full screen, if I want it to just look like a regular browser app. Those are the kinds of things you can set here. And you can do that all through Drupal configuration. There's also a module called Advanced Progressive Web App that does the same thing, but it also includes notifications. Push notifications might be overkill for anything you would want to do. Then I just have a bunch of resources at the end here for further reading. There's a lot to read. I would suggest the Going Offline book by Jeremy Keith. That's a great introduction. If you want to get further into it, there's plenty of resources on progressive web apps as well. All right. Quick round of questions. Anybody got anything?
Could you just name a couple of your favorite examples that you might not have mentioned of how you've seen this work out, hopefully, the real world ones?
So, I don't have any particular favorite examples. I would say that Jeremy Keith's site works very well with an offline offline functionality. So I would say go check out his site. Actually, you know what? The easiest way for me to do this is to just turn off Wi-Fi and then refresh. Oh, this is actually all right. So I am offline right now, right? You can see that it's working, and if I start to click around, you'll get something like this, the fallback message. Another really good one, it's a developer agency. Sorry?
Turn Wi-Fi back on?
No.
Oh.
I'm going to try without Wi-Fi, because this is a service worker. Cloud4, they do some great stuff with service workers. Also wrote the book on progressive web apps. So this is offline. Yeah, they did a really nice job. Those are the ones I've seen. I've heard good things about Starbucks has a web app. But I haven't actually used it because I don't drink Starbucks.
Uber has one too.
Oh, yes, I've heard. Actually, I've heard Uber's progressive web app is better than their native app. I don't know. And I think Airbnb.
Trivago probably.
Yeah.
Or, I mean, maybe Airbnb, I don't know.
Yeah, I wasn't really aiming for a progressive web apps presentation, so I didn't really compile too many, but there's a lot to find out there. Any other questions?
Is it safe to say that the service worker's role, I mean, it's basically about requests for information, caching strategy? There's no need to use it just for having multi-threaded operations going on. I mean, you can run asynchronous, like you can run parallel stuff in just pure ES6 or whatever it's
Yeah, I mean, the nice thing about it working that way is it's not having any performance impact while it's dealing with this caching stuff, right? So I'd say that's the number one kind of, even if it's just another thread rather than the DOM thread, just a single separate thread, that you're not getting any kind of glitchiness or usability impact while interacting with the DOM.
Oh, but it could do other things too.
Sure.
Like, if you want to translate all of your content into pirate speak on the appropriate day of the year, I forget what it is, then you could intercept your requests with the service worker, right?
Yep, absolutely.
I don't know how else you would do it.
It would be
Oh, but that would only work for your own site?
right by design. So I would suggest looking at that service workers cookbook. The Mozilla resource. There we go. This one. You can see lots of examples of different kinds of caching strategies.
One of the examples I've seen are like, they request this, or you're offline, let's give them that, which is pretty cool.
Yeah.
It feels like there are other use cases, maybe.
Yeah, I mean, it's new ground.
Yeah.
And I think we don't even, people are really experimenting with this right now. The Drupal modules, by the way, they're also very simple use cases.
Yeah.
And if you want something that is more tailored to a site, anything beyond just a simple offline page, then you're probably going to roll your own and start to get into the JavaScript code for that.
Yeah. Okay. Makes sense.
All right. Thanks, everyone.
Thank you.